Good morning, guys. We will be continuing our session. This is regarding binary addition. In our last lecture, we did the interconversion of binary, decimal, and hexadecimal number systems. You saw how we can change a decimal number into binary, a binary into hexadecimal, and hexadecimal to decimal, or vice versa. So that is the mathematical procedures which you need to practice, and I also shared a video link with you in which it is explained in using various techniques, and it's very easy. All you need to do is the practice, and you can find the questions, various questions on the internet, and you can make up your own questions. You can think of any number and you can start converting it into binary, into hexadecimal, and then convert back into decimal number system to see if you get the same number back or not. So after that, the next topic and the next stage is to go for simple mathematical procedure, which is one of them is addition. So as you know that all digital systems, computers, calculators, mobile phones, all of these computer related systems, the digital systems, they understand the binary language. Okay, any number which you type on a calculator, it is in decimal, but when it goes to the processor of the calculator, it has been converted into binary, and the processor of the calculator is only it only understands the binary language. So if you type on calculator 10 plus 50, what is the answer? It will show you the answer as 60, but in the background your number 10 and your number 50, it will be converted into binary. The processor of the calculator will add those two binary numbers together and it will find an answer. But that answer is in binary. It will be converted back into decimal so that you can see the decimal answer on the screen. Because we human being, we are used to the decimal number system, not the binary, but our machines, they work on the binary. So that interconversion is a normal thing in digital world, so you will always see that. So this topic is about binary addition. So this is the truth table which you have seen most of the time. I mean, this truth table relates to the OR gate. Excuse my writing because I'm using a mouse. So OR gate truth table looks like this, and OR gate also, I told you, it relates to the summation or addition type of thing. Okay, so in that you can see that here the input A and B, the first row says if both are 0, the output is 0. If any one input is high, the output will also be high. But look at the last row. This is the important thing which I need to show you. Look at the last row here. That 1 plus 1, what will be the answer? Usually we just write 1, okay, that if both inputs are high, the output will also be high. We do like that, and we ignore the fact that the answer is actually 2 digits, not 1 digit. Okay, but actually when you do in binary, when you add 1 plus 1, what happens? Let me write it here, 1 and 1, and if you add it, okay, so 1 plus 1, remember we are not in decimal, we are in binary. Okay, in decimal 1 plus 1 is 2, but in binary 1 plus 1 will be 0. Okay, and then there will be carry of 1. Okay, that carry will come down here, and it will give you, you will write 1 here, and your answer will be 10. So 10, this number which is in, this number is in binary. If you convert it into decimal, it is equal to 2. You can do the conversion. Okay, this 10 is actually binary 10, and you convert it into decimal, it will come out to be as number 2. So this 1 plus 1, why it is 0? If you remember in decimal, see 9 plus 1, what is the answer? 9 plus 1, you write 0 here. Okay, and then there is a carry of 1 which goes on to the next step, next stage, and then you brought it down and you write 1 here, so the answer becomes 10. Okay, the same procedure here in binary. See, because in decimal there is no number higher than 9. Okay, if you add 1 into 9, it will be 0, and 1 carry will go on to the next stage, and it will become number 10. Okay, in a binary there is no number higher than 1. Okay, so 1 plus 1 will become 0, and 1 carry will go on to the next stage, and it will become 1 0. So the same thing here is shown in this line, the last row. 1 plus 1 is actually 1 0. In the truth tables before, you must have seen only one written, and we ignore the least significant, but this is the complete answer, which is the 2. So now this thing, okay, now here are in this PowerPoint slide is available in the contents in the teaching material. You can refer to that. Here are some examples shown here. See, this is the binary number, and these are the, this is the binary, and this is the equivalent decimal. Okay, so this
This is
number is
base 2
actually
and this is
21
base
in
10.
decimal, and this number is actually 25 in decimal. So the addition is done for you so that you can see the both number systems side by side as a comparison. Now look at this. 1 plus 1 is 1 plus 1 is 0, and you
Is
see there is a
0.
carry
It's 10.
going
It's
to
like,
the next
teacher,
stage.
hello?
So 1 plus 0
Can you
plus
hear me?
0, it will become 1.
Can
Okay,
you hear
and
me?
similarly the simple addition will go on, and in this stage as well, 1 plus 1 it becomes 0, and carry going on to the next stage, and you will get 1 here. So if you convert this into decimal, you will get this number. You can try it, and you will get the same thing. So now this binary thing, which we can do it manually, okay, all of this, how can we do it using our gates, logic gates? If we want to use a logic gate, a combination logic gate circuit, and we want it to perform this addition function for us, how it will happen? So that is called binary half adder logic combination circuit, okay, which we will see here. In this slide, you will see binary half adder with AOI logic. What is AOI? A for AND, O for OR, I for inverter logic. If you see in this combination logic circuit, you see three types of gates: AND, OR, and NOT. So I will show you how this logic circuit work on MULTISIM. Let me share my screen. Are you able to see, guys, the MULTISIM screen?
Yes, sir. What is this?
Please respond if you can see the MULTISIM screen. Guys, can you hear me? Okay, you can see that's fine. So, okay, now I'm on my multisim screen. This is the same circuit which you saw on the PowerPoint slide. I have made it on the multisim. Okay, this is input A, this is input B. To show the level of input A and B, I have placed two LEDs, blue and green here. Okay, just to show the high and low level. Now, input A is going to this AND gate through a NOT gate. Okay, input B is going to the second AND gate through this NOT gate. Okay, uh, this AND gate, of course, it has two inputs. So one input is coming from A through a NOT gate. The second input is coming from the line B, input B. Input B is going straight into the first AND gate. Similarly, in the second AND gate, second input is coming directly from A. So you can say the first AND gate, it has inverted A and B as input. Second AND gate has input A coming from here and inverted B. Now both of these AND gates are giving their outputs, and these outputs are going into a OR gate. This is the OR gate, and this OR gate is actually giving you the sum. Sum means addition of the two numbers. It will show you here. Now what about the carry? Because there is a I mean, in some cases where the number becomes higher most, then you have to get to the carry. So the carry, for the carry, there is third AND gate here, which is, you can see in the bottom, and its one input is coming from input A, second is coming from the B. Okay, so this you can see. So now I will run this, and input and B are both high. Let me make it 0, both of them 0. Okay, as you can see, I can either click on it and switch between 0 and 1, or I can use the key A on the keyboard to switch. So this is the first case when input A is 0, input B is 0. You can see the LEDs are off, A and B, and you can see that the sum and carry LEDs are also off. So in this case, no input, no output. Now let me go for the second case in which input A is 1 and B is 0. See, A is 1, B is 0. On the output, sum is 1 and there is no carry because 1 plus 0 is 1. Okay, now third case in which A will be 0 and B will be 1. You can see A is 0, B is 1. Sum is high and there is no carry. Fourth case in which both input A and B are high. You can see now A is high, A is 1, B is 1. Both LEDs are high. Now here, look carefully. Now the sum has become 0, but there is a carry 1. So this is actually 1, 0. Carry is high, so it means it is 1 and it is 0. The same thing which I showed you on the truth table. Okay, so that's how the logic gates can do the addition function for you. And we have seen from the behavior that is doing the addition correctly. The same thing which we just checked on the truth table, the same thing is being executed by this combination logic circuit. So this is 1 0 now, which is equal to 2 in the decimal. I will stop this simulation. This is one circuit. There is one circuit in the presentation which I will show you here. Okay, it is doing the same function with less number of gates. This combination logic circuit is called XOR half adder. Okay, this is XOR because you are using a XOR gate. In the other circuit, we did not use any XOR. So in this circuit, we are using XOR, and it will do the same thing as before. So let me start. I will make both the inputs 0, 0. Input A is 0, input B is 0. Both lights are off at the input. On the output, the sum is there, carry is there. Sum is being provided by this XOR gate. Carry is being provided by this AND gate. Okay. So I will do the same procedure. First case 0, 0. Output is also 0. Second case, when A is 1, you can see A is 1, B is 0. On the output, sum is 1 while there is no carry. Okay, now I will go for third case in which A is 0, B is 1. You can see from the lights A is 0, B 1. On output, sum is 1 and there is no carry. Fourth and the last case, when both inputs are high. Both the inputs are lit, you can see. And this time, sum becomes 0 and it transfer the carry onto the next stage, which is now giving light. The carry is showing red light, so it means the answer is now 1 and 0. So for carry 1, sum is 0, so 1 0 is equal to 2 in decimal. So this circuit is also performing the same addition function, but with less number of gates, only 2 gates, while in the other circuit, how many gates you are using? 6. Okay, both are doing the same job. Now if you want me to make this circuit, or you can give it a try. Okay, this thing is recorded on the video, and you can refer to my previous session on multisim, in which I showed you how to bring up the gates from the place components and all that. Okay, and these are the similar gates which we used before. So you can try this combination. You can refer to the PowerPoint to see the circuit, or you can refer to this video. Okay, and your task is that if you want to practice, you can make the same circuit by yourself and see if you also get the same result or not. So guys, any question about this combination logic circuits, uh, half adder?
Hello.
Okay, there is a problem. I cannot hear you guys. I don't know why this happened. This problem is there in the blackboard. Whenever you switch uh, from one session to other, something happens. Yes. So I have faced this so many times. So I don't want to log out at this moment. If there is any question, you can maybe type it in the chat. Okay. I will just show you in the presentation. See guys, this was the circuit which you saw first one. The first circuit was this one with the AOI logic, AND gate, OR gate, and inverter logic. So this was the first one. It is doing this truth table actually. Okay, the next one which was having less number of gates is this one, and this is with XOR logic because you are using a XOR gate. Okay, and it is also doing the same function as the first one. Okay, both the logic half adders, basically they are called binary half adder circuits. Both are very easy. You have design in front of you. If you have multisim on your computer, you can refer to my this video and my previous video in which I showed you how to use multisim, and you can easily create this half adder yourself, and you can see if it is giving the correct result or not. Okay, so any question you can post on the chat, I will be answering them. I will stop the recording here so that you can refer to it later on.